In this video, I will be discussing whether electric outboards are a viable replacement for petrol outboards. I will use my personal boating application as an example, which is a 3.2 metre inflatable, a Homwave T32 to be precise, with an 8 horsepower outboard. I'll be comparing an electric outboard to a petrol outboard in terms of economy, being cost of purchase and ongoing costs, practicality and other pros and cons. The two outboards I will be comparing are the Tohatsu 8 horsepower 4-stroke and the Tokido 8 horsepower equivalent, the Cruise 4T. So, starting with the petrol. Tohatsu 8 horsepower retails for around £1,500, and I found it cheapest for sale online for £1,419, excluding the fuel tank and line, which would be less than £50 for a 12-litre tank and line. Whereas the Tokido Cruise 4TS retails on their website for £3,149. The outboard is 4,000 watts, which is only 5.4 horsepower, but they say it's equivalent to an 8 horsepower outboard. The electric motor also needs a battery, for which they recommend their own lithium-ion 48 volt, which is the same as the motor, 5,000 watt-hour battery, which retails again on their website for £4,399. This battery would give 1 hour 15 minutes of runtime at full throttle, or under 2.5 hours at half throttle. So for my usage, I would probably require 2 batteries, which would provide double the runtime, but costs 2 times as much. This brings the total cost of the electric setup to £11,947. So it is clear that the purchase cost of the electric motor and the battery far exceed the purchase cost for the electric outboard. But can this difference be made up in savings from the running costs? One 5,000 watt hour battery costs 92p to charge from the national grid, so the price for 2 batteries is £1.84. Whereas I tend to use 8 litres of petrol, which at prices currently of £1.08 gives a total cost of £8.64. So our savings per run, per trip, is £8.64 minus £1.84, which is £6.80. So, I tend to use the boat maybe twice a week in the summer months from June to August, but let's be optimistic and say 30 times per year. So this would be £259.20 of petrol, or £55.20 of electricity. So the difference in cost between the petrol setup and the electric setup, savings, would be £204 per year. But the difference in cost between the petrol and electric to purchase is £10,447. So I would have to be boating for 51 years at the rate I do and the cost of petrol to break even, to justify the electric cost. However, this is completely unreasonable, because even if the batteries are rated for 3,000 charge cycles, it's reasonable to say that the lithium-ion batteries will not last more than 10 years. So, given this, at what usage is it economically viable to buy an electric setup instead of the petrol? So, the difference in price, 10447, over £6.80 saving, gives us 1,536 trips, which is below the 3,000 charge cycles of the battery, so it is possible, before it is economically viable. So over 10 years, which I think is a reasonable lifespan of the batteries, which is 10 times 365 days, so 3,650 days, you would have to use the outboard once every 2.4 days, or 3 times a week. Using the outboard 3 times a week for 10 years would get you the number here. I guess this is possible if you're a commercial user, but for a summer leisure boat it seems unlikely. A side note, if you used it 3,000 times, which in theory is the maximum, you could save up to £9,923. However, this is ignoring one important factor: petrol. Petrol prices, to be precise. If they went up, all these numbers would change. In fact, if petrol prices went up to £4.58 per litre, it would be economical for me to have bought an electric outboard instead of a petrol outboard, given a 10-year lifespan and my current usage.